Okay, so here we go with lesson 4. In lesson 4, we're going to be learning about trig equations that are linear, so first degree. So when you think about linear, we're thinking that the power is 1, of course, like always. Okay, so when solving a trig equation, what we're going to be doing basically is trying to solve for the trig ratio and then using that information from lesson 3 to determine all of the angles that satisfy an equation. Our solutions in this case are going to depend on an interval. So the interval might be from 0 to 2 pi, and it might be all real numbers, so you have to pay attention to that at the beginning of the question. Okay, so I've got the steps written here for you. Isolate your function, might already be done for you. Once you've got that, determine the quadrants where your angle will be, either positive or negative, using our ASTC rules from last class. Determine your reference angle as well, using special triangles if they apply. If they don't, then you'll just use your calculator, inverse of your function, to find the reference angle, and then find your standard positions from there. So we're going to look at about 5 examples here in this lesson. In the first one, we're going to solve for theta, and the interval here from 0 to 2 pi. So any answers that we're looking for have to be in that region, nothing outside of there. And they've also told us that the sine ratio here is root 2 over 2. And by telling us that, they're actually telling us a ratio, right? An opposite and a hypotenuse sine ratio. Okay. So the first step would be to isolate the sine ratio, which is already done for us in this question. So we'll move on to the second step, which is to figure out which quadrants we're going to be in. Notice that the sine ratio is negative here. Okay, so ASTC rule says that sine is negative in quadrants 3 and 4. So I'm not in quadrant 1 or 2. So I'll draw a triangle, reference to the x-axis, like last class, okay, in quadrant 3 and 4. And so my reference angle, he's sitting right on the x-axis, there and there. And I'll fill in my triangle from my known information about the sine ratio, which is that the opposite side is root 2 and the hypotenuse side is 2. And so in both of these cases here, the opposite side would be negative root 2 since it's going downwards. Okay, so to fill in the reference angle, which is what I want to figure out next, so that I can find my standard positions, which will be my solution, I need to think, is this a special triangle? And in this case it is. It's hiding a little bit, okay, but this is actually the 45, 45, 90 triangle. Now, how do you see it? It's because the sides, which are normally 1, 1, and root 2, have all been multiplied by root 2 itself to get those values there. Now, if you didn't see that, you'd still use your calculator, and your calculator would tell you a reference angle of 45 degrees. So it wouldn't actually matter. Okay, so our reference angle here is 45, or since they've given us radians in the question, we should answer in radians as well. So the reference angle here is pi over 4. Okay, that's really the hard part. Once you've got that, the two solutions in our interval are going to be theta 1 and theta 2, we can call them. The first one is in the third quadrant, so that'll be pi plus pi over 4, which is 5 pi over 4. And the second one, which is in the fourth quadrant, will be 2 pi minus pi over 4.
Attention, please, attention. The students who have gone to the Japan trip, please go to a meeting now happening in C336. Thank you.
Sorry about that. Okay, so the second one in fourth quadrant, 2 pi minus pi over 4, which is 7 pi over 4. So we have two solutions for this question, and you can check them by using your calculator. So make sure you're in radian mode, and then plug in sine 5 pi over 4 and sine 7 pi over 4. You should get negative root 2 over 2 as a decimal, so whatever that is. Okay, so there's the first question done. Second one, so this time I'm solving for beta, which is just a different variable for our angle, and I have the same interval from 0 to 2 pi. This time they told me about the secant ratio. Okay, now secant is kind of hard to work with. The reciprocal functions, they're not as easy to work with, so I'm going to change it to cosine because I know better about him. Cosine, I'm just going to flip the side on the other side since it's reciprocal. So 1/2 and it's negative. Okay, that one's more familiar. From here the question becomes the same because this is really talking about adjacent and hypotenuse. Okay, so I'm going to start by isolating my function, already done. I'm going to figure out my quadrants. So using my ASTC, this time cosine negative. So cosine is negative in quadrant 2 and 3. So draw your triangles there. right? And then we need to use that to find our reference angle. So what is theta r? Okay. Now this one is also a special triangle. Fill in your sides. The adjacent is a 1 and the hypotenuse is a 2. So this is the 30, 60, 90 triangle. If you want to fill in the whole triangle, this side would be a root 3 and a root 3. So the 1 is opposite the small side, sorry, the small angle, which is 30 degrees, which means that our reference angle here is 60 degrees. Since they gave me radians in this question, I should answer in radians as well. 60 degrees is pi over 3. So there's my reference angle. From there, all I need to do is go back and figure out what is the standard position in my interval, 0 to 2 pi. So the first one in the second quadrant will be pi minus pi over 3, which is 2 pi over 3. And the second one in the third quadrant there will be pi plus pi over 3, which is 4 pi over 3. Again, you can check them in your calculator. Now you can't plug in secant in your calculator because there is no secant button, but you can plug in the cosine, so that still works. Okay. Note here, when solving for an angle, ignore the negative sign, right? Because that's already been taken care of by finding the right angles, or sorry, the right quadrants. By doing the ASTC thing, it's taken care of the negative. So once you've done that and you know your quadrants, you can actually ignore the negative altogether. It doesn't make a difference. And of course, answer in exact values when possible. So that just means special triangles. Be on the watch for those guys. Okay, so example 3 here. Solving 3 tan theta plus 5 equals 0, only from 0 to 360. So notice that this time I'm looking in degrees, so my answer should be in degrees, not radians. Okay, this time I have a little work to do first. I need to isolate the tan function. So I'm going to move the 5 to the other side and divide by the 3. And then this is what I'm going to deal with. So tan function, so I know that this side is the opposite, this side is the adjacent. So I'm going to figure out my quadrants. Tangent negative. So ASTC tells me I'm in 2 and 4. So draw your triangles there. And then you can fill in the sides as well. Opposite side here is 5. And adjacent side is 3. Now in quadrant 2 here, the negative would be on the 3, and in quadrant 4 it would be on the 5. But that doesn't really make a difference for our particular purposes. Okay, find the reference angle. Now in this case we don't have a special triangle. 3 and 5 are not any of those special numbers. So I'm just going to use my calculator and I'm going to do inverse tangent of my ratio, ignoring the negative, because we already took care of that. Okay, so what I get when I do this in my calculator, I'm going to make sure I'm in degree mode because my answer should be in degree. So inverse tan of 5/3 gives me 59 degrees. From there, I'm almost done. I need 2 solutions here, theta 1 and theta 2. The first one in the second quadrant will be 180 minus 59 degrees, which is 121 degrees. And in the fourth quadrant, it'll be 360 degrees minus 59 degrees, which is 301 degrees. And there they are. Again, check them in your calculator. 3 times the tan of each one of those angles plus 5. If you're in degree mode, should give you exactly 0. Might be a little tiny bit off because we rounded our reference angle. Okay, on the back page, the first thing we have here is something that's not really an example, but rather a major concept that you want to sort of know about because it's kind of a weird one. It's called quadrantal angles. Now, sorry, there's other students talking in here. The first part of that word is quadrant, and that's no coincidence. It's because these are angles that lie right on your quadrants, so in between quadrant 1 and 2, for example. So they're a little funny because you can't really draw a triangle. There's no triangle if you're sitting on the y-axis, for example. So they're just good to know about. You'll notice that for each one of these ratios, you have 0, 1, or negative 1. Now, if you see the ratio 0, 1, or negative 1, that doesn't necessarily mean it's quadrantal, but odds are good. The only exception would be tangent. So we're just going to go around the circle and look at what happens on each individual quadrant. So if I'm right on the x-axis, in between quadrants 1 and 4, what I know at this point is that the y value is 0. In other words, the opposite side. So y you can think of as the opposite, x you can think of as the adjacent, and r, the radius, is really the hypotenuse if you draw the circle in. So at this point, y is 0, and x and r are exactly the same. And you can use that information to fill in your ratios. So the sine ratio at this point would be opposite, which is 0 divided by hypotenuse, which is r, whatever it is. 0 divided by r would give me 0. Cosine at this point would give me adjacent, which is x divided by hypotenuse r, and they're equal, so it gives me a 1. And then tangent, opposite, which is 0 divided by adjacent, which is x, gives me 0. Okay, so going around the circle in this way, if I go up to 90 degrees now, at this point x is 0, and y and r are the same. So using the same information, I can figure out that sine ratio here is 1, since they're equal, opposite hypotenuse. Cosine ratio is 0, since adjacent is 0. And tangent is actually undefined, because it's dividing by x, which is 0. Okay. Keep going to 70 degrees, here I am. So at this point, now I've got x and r the same, but opposite signs, so negative. And then y is 0 again. So in this case, my sine ratio would be 0 again, since the y is 0. Cosine, they're equal but opposite, so negative 1. And tangent, again, is going to be 0. And down here, okay, so in the last quadrant, in between quadrants 3 and 4, I've got x 0 again, and y and r the same, but opposite sign. So I can find then that the cosine or sine ratio is going to be 0. No, sorry, negative 1. Negative y over r. Cosine is going to be 0, and tangent again is undefined. Okay, now you don't have to memorize these because you can use your calculator to check them out, but sometimes if you're solving an equation and you get sine equals 0, it's a little confusing. So it's just nice to be familiar with each of these quadrantal angles. So let's try, before we do that, general solutions is the last concept here before we do 2 more examples. General solutions just mean that the interval is all real numbers. So instead of writing a specific solution in an interval, what we need to do is very similar to when we had coterminal angles and add 2 pi n to our solution, where n is an integer, right? In other words, all possible angles, coterminals included. So example 4, sine x equals 0 for all real solutions, in other words, general solution. So we'll add 2 pi n at the end of our answer. Sine x equals 0. Now that's a quadrantal, okay? So you can try to draw it, but it's hard to draw since it's not really a triangle. Sine x being 0 means that the opposite side is 0, and the hypotenuse side is whatever it is, 1 by default if you want. Okay, but opposite being 0 means that the y value is 0. So if you try to draw it, figure out your quadrants, what you'll find is that you're drawing something that has no y. In other words, it's on your x-axis. Okay? So for this particular question, if it has no y, sine is 0, that means that theta 1 could be 0, and theta 2 could be pi, or 180. They didn't say which unit to use, so either one would be fine. So those are both solutions from 0 to 2 pi. 2 pi, I guess, could include 2. But they want a general solution here. So for those guys, I'm going to add 2 pi n, add 2 pi n, where n is an integer. Now that would be fine if you left both of those, but we can actually condense it into one nice solution, because for this question, it rotates half a circle each time. So what I would do here is take one of my solutions, doesn't matter, you could start with 0 and then add pi n. So if you have 0 plus pi n, where n is an integer, that's even better. And you don't actually need the 0 for this question, so actually just putting pi n would be everything, where n is an integer. And there's a nice solution. It's all together, it includes every single answer you can dream up. Okay, so last one here, example 5. We've got tan x equals 1, and again they want all real solutions, so there's our general solution again. Now tan x equals 1, you might think that that's a quadrantal because you see the 1, but let's think about it. Right, this is saying opposite is 1 and adjacent is 1 by default. Okay, And that's saying that the opposite and adjacent are the same. It's actually an isosceles triangle. Let's draw it. Tangent's positive. Find your quadrants. So that's going to be in quadrant 1 and 3. Here and here. Okay. Let's find our reference angle. So my opposite is a 1, my adjacent is a 1. Down here they'd be negative. And that's actually a special triangle. It's the 45, 45, 90 triangle. So my reference angle here, pi over 4. Okay, we can find our two specific answers in each of those two quadrants. So theta 1, I guess I should use x since it's the variable they gave me. x1 and x2. x1 in the first quadrant, just pi over 4. Oh my goodness. And in the third quadrant, pi plus pi over 4. So 5 pi over 4. So those are specific solutions. They want general solutions though, so I need to add 2 pi n to each of those where n is an integer. Now again, since these ones repeat every half circle, I can condense it into one nice solution where I say that x is the starting point, which would be the pi over 4. You could use 5 pi over 4 as well, that would be fine. And then instead of adding 2 pi, I'm just going to add pi and half a circle. And n is an integer. And that's a little nicer than writing it out twice with 2 pi n. Okay, so the homework for this lesson is just the one worksheet that you've got, just the first 20 questions. They're all linear, and then the second ones will be quadratic and more complicated, but that's lesson 5.